Okay, sounds good. Hello, everyone. My name is Dan, Head Education founder. I'm here with our guest speakers, Mr. Mauro and student TA, Claire, Richard, and Bright. So what we will do is we have Mr. Mauro and the student TA take your turn to introduce yourself very briefly. I will take 2 minutes, share a little bit about Hattie, since not everybody knows about our company. And then we'll have Mr. Mauro give a brief introduction about the program, and then I will be hostess to interact with all the panel speakers and ask them a few questions. We'll save about 20 minutes for all the audience to ask questions, and at the end, I think we will wrap up around 6:05, about an hour. Okay? Yeah, thank you. Okay, Mr. Mauro, you go first.
All right. Hi, everybody. Thank you for coming, and thanks for all my former students at the previous camp for attending. Appreciate everybody being here. So my name is Tony Mauro. I am an electrical engineer trained. I worked in industry at big company in San Diego called Qualcomm. Many have probably heard of it. For 20 years. That's where I met and worked with Dan. Uh, very closely. Um, I started teaching in 2008 at a local high school in San Diego, a public high school, and did that until 2015. And I retired from the high school district then, moved to the Bay Area. So I currently live in Marin County in a little bit north of San Francisco. I still teach with UCSD, so I'm an instructor over there. I work remotely with the several groups where I teach machine learning and digital circuit design. So many of the things that we're going to be doing in this camp are based upon the kind of things that I teach at UCSD, to combine both the hardware and software, and I'll talk about that in just a little bit. So nice to meet everybody and hope you get something out of this camp.
Thank you, Mr. Mauro. Claire, lady first.
Hi, I'm Claire. I'm a rising, okay, so I'm currently a junior at Torrey Pines High School. It's in the same district that Mr. Morrow used to teach at. It's in San Diego. I went to the camp last summer, and I'm excited to meet everyone.
Thank you, Claire. And Richard?
Hi, I'm Richard. I'm currently a sophomore at Doherty Valley High School in San Ramon. I also took this camp last year. It was an amazing experience. I got to meet a lot of new people, and I'm really excited to meet you when this. Yeah, thank you.
Thank you, Richard. Bright?
Hi, my name is Bright. I am a junior at the Orange County School of the Arts in Orange County. I also attended the camp last year, and I'm really excited to meet you guys this summer.
Okay. Thank you. So now I will take 2 minutes, share about Hattie. Okay. And you can Google us, Hattie Education. A lot of Google reviews, not going through here. We have two physical centers, one in San Diego. The one address there is in San Diego. And the other one is Berkeley, right next to UC Berkeley. And this is a research website. We made this with AI. And we put our summer program, and then we have a lot of one-on-one research with different professors. Okay, so I will send the link down there. And our official website was designed by our students many years ago, student interns, and we have variety of education resources. Okay, and our main resources is college counseling. Okay, so I'm not going to go through in details here. And last year, actually, our Google review site was during transition, and the students like Claire, all of you very nicely, and the parents too, give us very nice review and very authentic. We never pay anything for review, okay? Every single review is organic, okay? Thank you all. So this happened to be a website for the last year's students and parents review about this camp experience, and you'll get to know about camp today. And we have one more thing. We have YouTube, and the YouTube channel, it's Hattie Education. I will send you a couple of videos. We have a video with Miss Mauro and in details talking about the in-person programs at UC Berkeley. Okay, so that's about it. And I will give the screen share to Miss Mauro. Okay, so how do I do that? Oh, 1 second.
So,
Yeah.
I just sent a request to share.
Okay. Yeah. Allow. Good.
Okay.
Thank you.
All right. So hopefully everybody sees my slide deck. So this is the initial slide, the intro slide. What we're going to talk about today is the Machine Learning and the AI Foundation Summer Camp. We're going to hold it at UC Berkeley, and it's in the late July timeframe, so from 20th to 31st. And again, my name is Tony Mauro. I teach computer science and circuit design, so hardware and software. And so part of the motivation for this camp was really to address some of the kind of the divides between software and hardware, and sort of try to merge both of these disciplines together, so that the students who attend the camp get a feel for what it is that the hardware does and what it is that the software does in machine learning and AI. And so we're trying to address these kind of really critical areas in this field. So what we're going to do is provide a comprehensive introduction to both software and hardware, those foundational components, to address those who are interested in pursuing fields in either data science, machine learning, or hardware design, or all three. And as this whole industry sort of evolves and is moving quickly because of all of the advances in large language models and the hardware associated with it, there is a melding of these two technologies. I personally think that in the future, the engineers that originally were very siloed into either hardware or software are going to start really merging together. And so there's going to be a lot of kind of synergy between those two. So we think it's important that students have a good feel for both the programming part of it and the circuit design part of it. And so we're going to have two parts to the camp, and we'll structure it the same way. And fortunately, we have really the students who are here, the three that are here. These all were top students in the class, so they can give you a real good view, an honest viewpoint. And we didn't prime them with any any marketing or anything like that. So they're going to give you honest answers. I'm very open to receive feedback on what worked and what didn't work, and so they can give you some honest opinions on how it worked. But we break it up into two parts. We split the day up. It's a full day for the whole 2 weeks. And the first part of the day, we talk about the software side of it. And then the second part, we talk about the hardware side of it. And as we kind of progress through the 2 weeks, we start trying to push them together so that we get a feel for how they work in tandem, which is what it is in the real world. For the programming part of it, there are really three main sections. We look at basic foundations that have to do with Python. That's kind of the de facto programming language for machine learning with the libraries that are available, and then the mathematics behind machine learning. So, this is something that I teach over the course of 3 quarters at UCSD. We are compressing a lot of this stuff into 2 weeks. So there's a lot of stuff that goes on. We don't cover everything that I cover in the whole year, but we cover a lot of the foundations that you need for both Python and what the mathematics behind it are. Talk about some algorithms. So we cover a couple different algorithms, and then in traditional machine learning. And then we start an introduction to deep neural networks. This is towards the end of the the 2-week period. And so by then the students are normally pretty saturated with the content at this point. But we do hit what a neural network is and how they work. On the second part of the day, we cover circuit design for machine learning. So we covered some basics. What is a combinational circuit? What's sequential logic? What are the applications? We use a tool that is actually used at UC Berkeley, a schematic capture tool called Logisim. And then at the end, we cover an introduction to what a hardware description language is, which is more relevant to how real world designs and digital design um, are implemented. And then we go into, well, what does it mean to apply a hardware description language with a circuit design to machine learning? So specifically, how would you do a basic neural network comprised of a multi-layer perceptron model? So perceptrons are like a single node model for a machine learning for a deep neural network uh, architecture. And so we cover all that, and it is, like I said, very fast paced. And again, the students who are here can attest to how much we cover. It's a lot. We normally will. We spend the first day going through kind of some fundamentals, and in the mornings, and then in the afternoons in the mornings are covered with the software, and then the afternoons are covered in the hardware side. Um, and as we go through each day, what I normally will do is sort of review what we learned the previous day, introduce new concepts, give students some time in the classroom to work through some of the material. Lots of coding, lots of hands-on coding, and then in the afternoons, circuits, or we're actually building things. And then there are some activities to do in the evening. So essentially homework to do so that we're prepared for the next day. So again, lots of things to cover. And I won't go through every item in this list, but we'll make this slide deck available to everybody so they can see. But basically, Python, introduction to digital logic and combinational logic, machine learning libraries, the kind of the standard ones that are used, combinational logic, introductions and some projects there. Um, More with libraries and exploratory data analysis. So we go through that and how you would use the libraries. Then we get into sequential logic. So this is clocked components. Then we'll talk about some applications. One of the kind of the fundamental and famous algorithms that everybody learns in machine learning is one called gradient descent, which is a cost minimization algorithm. Then we'll get into what a state machine is, do some projects related to that. We do some catch up. In the camp that we had this last year, I made the assessments optional. I want the students to learn things, but I don't want to have them feel like they're in a kind of a traditional classroom where I'm just going to give them a bunch of tests throughout the week. I come around and I will validate that they know what they're doing, and so this last camp, we didn't do formal assessments. I was assessing them as we were going through the projects. In the second week, we go through another algorithm called linear regression. It's another kind of famous algorithm, or kind of fundamental one. We look at hardware description languages. This sort of pushed out a little bit. I think we covered this towards the end, like a little bit. It delayed out a little bit because we were working on projects in the hardware space. We were actually building some circuits, and so it got a little bit more in the afternoons. It kind of stretched out a little bit. We look at classifiers. The main one we look at is naive Bayes, and I think Claire used that on her project. Um, And then we'll go into in the afternoon we go into more logic with hardware description languages. Finally, at the end, we talk about neural networks and then introduce a capstone project where students have the option to create something, whether they want to do a strictly software-based, machine learning algorithm implementation, or a hardware-based um, project, or some combination of both. And they have that freedom to do that with some guidance from me. And now with this next one, it'll be through guidance of me and the TAs. So there'll be a lot of good got a lot of good people to help everybody go through that. So that's basically it. Lots of stuff that we cover. The prerequisites and preparation. So to have some basic Python programming knowledge, I have sort of an entrance assessment to kind of test your skills and to make sure that you have kind of just a basic understanding. We use a what's called literate programming environment or Jupyter notebooks, or we use Google Colab, which is a notebook-based approach to the coding. We use like I was saying, a schematic capture tool called Logisim. So students should have some basic programming knowledge. It's not critical that they know Python, because we go through stuff from the very beginning, but it's very fast. So you have to come up to speed pretty quickly. Basic logic functions. What is an and function or a not function? And again, we cover this in the course, but it's pretty quick. So if you have that knowledge, that's great. Algebra 2 minimum. You don't need to know calculus coming in here. There is calculus in neural network backpropagation discussions that we actually go through, but I try to water it down enough so that everybody kind of gets an idea of how that works. Students, you should have your own personal computer. It's a bring your own device. Have a Chrome browser so that you can get to Google Colab. Have a Gmail account so you can get the account set up. I'm going to be doing a distribution of everything through a Google Classroom. Most students are pretty familiar with this, so if you have this setup, it's good. We use Tinkercad. That's there's a cloud-based schematic capture tool and kind of um, uh, a simulation environment that lets you prototype your designs in simulation world before you actually build them as a prototype with a breadboard. Logisim evolution requires that it's a jar file, so it's a Java application. So you need to have a JDK installed. So Java development kit. Again, many people already have this installed. The evolution, Logisim evolution is what we use, and that can be installed. All these tools are free. For the HDL tools, I use ModelSim. It's a Windows application. Many people have Macs. I have a Mac as well. I run a virtual machine, one like Parallels. You can get a free version, a trial version of it that would more than cover uh, the time in the camp. Or an alternative is a cloud-based one that's free called EDA Playground, and it's getting better. It used to be kind of clunky to work with, but it's pretty good. So I have a lot of students who actually take my HDL class at UCSD, and they use EDA Playground, so it works pretty well. So that's kind of the basics of it, and I will turn it back over to Dan for her next topic.
Thank you, Mr. Mauro. Yeah, there are a couple of things I forgot to mention. We had two rising seniors last year, and two students placed really well. One got into UC Berkeley, the other student got into UC San Diego Engineering. We're very proud. And one student did the machine learning with Ms. Mauro on the predicting public disease. So it's not like a purely engineering major, but AI it's in every single industry, every single major now. And the other students more hardcore engineering students. So we're very, very proud. And then the other thing is, Miss Mauro is my both my sons' teacher in high school. Both of them went to CCA, and I told Miss Mauro, my younger son, with CS and Math 4.0, graduating from UC Berkeley this year, and graduation ceremony is tomorrow. So he is heading to for a mathematics PhD in one of the schools in Chicago and UIC, but he also got into great schools like CMU and Cornell. So we're very proud. Thank you, Mr. Mauro, for teaching both kids. Thank you. Okay, so we'll start questions with the TAs. Claire, first, that what have you learned from the camp and what project did you do?
Um, I think I'll just talk about one of my favorite things I learned from the camp, and it's also what I ended up doing my project on. Um, One of the things that I liked the best was the naive Bayes algorithm we learned. I think it's a really good introduction to like a lot of the other things you will probably learn later on, because it's pretty simple. And then for my project, um, I ended up doing something about prediction. It was predicting like whether or not somebody would like a specific song based on songs they previously liked. It was kind of inspired by like Spotify because Spotify recommends you songs. And I did that with my roommate. Because one of the things we both really liked was music, but we had like a not necessarily very much overlap of music we liked. So we thought that would be a fun project.
Oh, that's great. Yeah, very good. Okay, thank you. And Richard, how about you?
Yeah, I really the sports are like really comprehensive. They cover a lot. What I like the best about it is that like you really start understanding like machine learning at like a really fundamental level. Like you feel like you're like actually you can see how the industry works. You can see why there's so much potential in it. And what I did for my final project was since I've like in the past I've been to a class about image recognition algorithms. I figured out that if I just use the similar learning algorithm from this I learned in this class to a data set of like fashion items like shoes, like shirts, like blouses, and I can use that learning algorithm to like recognize the fashion images. And that was my final project. It wasn't the most accurate because the learning algorithms were like quite basic, but but it was like really interesting, and I had like a lot of I had a really great time figuring it out. Yeah.
That's great. Yeah. And Bright?
Yeah, as Richard said, like we really like learn a lot and like do a really comprehensive deep dive of like machine learning, like not just like how to use it, but like the underlying like math and like implementations of everything. I really enjoyed learning about like digital circuit design. That's like AND gates and like flip-flops and stuff. And so for my final project, I did like a digital circuit implementation of like a keypad lock.
So you went on the hardware route. Okay,
Mhm.
very good. So Ms. Morrow, so here's a question with all the students and the parents. Like you taught, you are teaching the same curriculum to all the students. Last year we have 15 students, ranging as young as rising freshmen, as senior as college students, and rising junior in college students. And some parents are like, okay, I have a kid as college students. I'm not going to hang out with high school students, right? So how you ensure their learning experience are good and they are all being challenged? So that's a question for Mr. Mauro.
Yeah, I think that the material is such that many students have not seen it before, and so it's fairly new. If they have seen it, like Richard was one who had experience from another maybe another camp that he attended, and knew uh, some of the library functions that implemented, say, a classifier, for example. But his experience with it was with utilizing the library itself. And as what all three of the folks have mentioned, we really deep dive into kind of the uh, the underlying math and the algorithm of each one of these, different topics that we investigate. So it's not just a matter of, well, if you want to do a classifier, just call this function, or if you want to, build a neural network, just use, this library. We actually go into the detail of why things work the way they do. And so I find that most of the students, even though we had a wide range, and it wasn't even so much the age that was the range, because we had some college freshmen that were in the camp that were pretty novice when it came to things like Python programming and such. And so really it's a matter of putting lots of material out that is new to most people, and then providing kind of this scaffolding set of tasks to do. The way we set it up is with notebooks in the software side, where they have to build up from individual code cells, where they kind of do some things in the very beginning that are kind of basic, and then it gets progressively more complex as they move through it. So it is pretty challenging, I think, for most students. And again, all the folks that are here, it's great to get their view on it, on how hard things were. But I don't think anyone came out of the uh, and these are like the three top students, right? I don't think any of these folks here came out of this camp saying this was too easy. I didn't really learn anything. Um, so, and they can talk about that. But yeah, so I think the material definitely is challenging.
Okay. Yeah, thank you. So I also sensed I knew that Claire did the duet, like two. Richard, you did solo. Bright, how many people in your team? I forgot. Three or four?
I think I just worked with Jason,
Oh,
my
Jason.
roommate. Yeah.
Okay, okay, two of you. Okay, okay, yeah. So I think we have some other project. We have at least like three people. So Richard, you did solo. Well, good for you. So anyway, I know some of you have attended other camps, and some of you are going to some other camps. Claire, have you attended other summer camp? Can you kind of share some comparison experience?
Um, before before the camp, this camp, I went to UCLA Cosmos. It was cluster 6. Um, it it wasn't the same, but there was definitely a lot of overlap. Like a lot of okay, like for example, we both the camps use Google Colab, and I think um I learned the same, if not more, from this camp because my foundation from the previous camp wasn't as good. Um, this one went in more in depth into like the background of things and how the mathematics worked, and that helped me understand like why the algorithms worked and how they worked. Um, so yeah.
Oh, that's good. And how long was the camp? The cost?
Um, at Cosmos, it was a month.
Okay, okay. Well, that's good. Well, it's complimentary to us that you learn a lot. We're it's a very intensive 2 weeks summer program. Okay, very good. And so let me see what other question I have for. Okay, so now let's talk about the challenges. Okay, I know overall it's challenging, but you guys have learned a lot. I've interacted with all 15 students. Everybody felt very, very happy. They all learned a lot, and they're all coming from like students are doing variety of the background. We have students got into Wharton business summer program, which is very competitive. Is also doing business and learning AI with Mr. Mauro last year. Okay, so Richard, what is your challenge?
The challenge for me definitely was the work was a little bit challenging, but like I enjoyed it still. But what was challenging for me was like really grasping like the concept because like it could get like a little bit more abstract or it can get pretty complex. So like I had like literally like go over the lessons like go over and over a few times to like really understand everything because it's really new, it's really complex, but it's still a great experience. Yeah.
Very good, very good. And Bright?
Yeah, I think for me what was most challenging was like really understanding like the mathematical like concepts but like behind the things we were coding. Um, but overall like it wasn't like too challenging and I definitely like learned a lot. Yeah.
Okay. Okay. That's good. Yeah. So we'll count on your help to help kids with hardware. All right. It's a foundation, right? The both combined. Yeah. Very good.
Yeah, and I
Okay.
think the one thing, and Brett, you can comment on this too. The those because you were one who had a lot of programming experience coming in, and so from a challenge standpoint, those who are expert programmers don't necessarily know the hardware stuff. So I think that's probably part of the reason why you were gravitating towards the hardware because it was new and kind of interesting and exciting to you, something new to investigate. So I think that the fact that we cover both in the camp gives people options that who may already be pretty well versed in maybe the in the software side of things to get another view of this area, which again is kind of melding together as it evolves with the on the hardware side, and then vice versa. If you have hardware experience, maybe you want to get more on the software programming side or the algorithm side too.
Yeah, very good. Yeah, I mean, Mr. Mauro, you were system engineer lead in Qualcomm, and I was doing project management. And we all know that you can label, one as a hardware engineer or software engineer. At the end, right? Hardware needs software to be to power up. So as an engineer, you need to know both, right, Mr. Mauro? Yeah, but there's definitely the expertise in each field, right?
Yeah, definitely. And that's the kind of the real world, right? I mean, it's very rare, at least in the companies that I worked at, that had products that weren't just purely software.
Hmm.
And I don't know many companies that are just purely software. Um, there's always a component that maybe you're doing an embedded system, um, or you have to understand something about the architecture of the hardware. For example, if you're, implementing a new large language model, right? So you're implementing a transformer, which are the kind of the basis of why LLMs are so prolific right now. Um, there's a lot of hardware related to that make them efficient, and this is part of the reason why architectures like GPUs that NVIDIA and others have come up with are so are so efficient and so widely used in this space. So getting that kind of, that mix of both software and hardware, and understanding, okay, well, how does this work in a combined environment is pretty important. And so this is what we're trying to do in this camp more than anything is just to give people the exposure to both so that when they kind of move on, that they have informed decisions on where they want to go when they actually do their studies.
Yeah, very good. Thank you. Yeah, so a couple of parents and students asking about the age. Yeah, last year we had a rising ninth grade. That's absolutely the youngest we'll take. And also as senior as rising junior college students. And for a lot of college students who were not really exposed to the field, has basic Python programming, you're welcome to apply. You will not be disappointed. We can guarantee you. We have TAs last year from college students from UC Berkeley, both felt that they were challenged as well. By Mr. Mauro. And but at the end, all their capstone project, the students' capstone projects, all were all completed with excellence. Okay, so now about homework,
So,
right?
Dan, if I can just say one thing, I think that you asked a question earlier about, how is it that the students are challenged? That capstone project towards the end that we introduced about halfway through the second week is pretty maybe unique. I don't know if unique is the word, but it's important that everybody gets a chance to really explore an area that they're interested in. To a level that they feel comfortable with, right? I mean, I don't want everybody to have to do the same project at the end. They all get to pick something that they're interested in because if they're interested in it, they're going to work harder on it and and really dig into it. And so we had such a wide variety of projects that everybody had to present at the end, and we got a really good exposure of different ideas and different competencies in these all these different areas. So it was really pretty cool to see at the end, even though this is only a 2 week camp, there was a lot of stuff that people did, a lot of hard work for everybody.
Yeah. Okay, very good. And now about real work, Claire. So what's the like homework load, like assignment beyond? So the camp is from 9:30 to 5 o'clock. Miss Mauro came in early every day, and thank you, Miss Mauro. And we have about 90 minutes lunch break, but Miss Mauro is there, so a lot of it, one-on-one coaching by Miss Mauro. So we try to end at 5 o'clock because we have students that commuter, students from Bay Area. Some of them will be picked up. But at night, and kids like Richard, you were a commuter student, and you went back and continue doing your work. So Claire, maybe you can shed some light about the homework load, and the collaboration too, which is very important.
Yeah. So there was definitely a lot of homework, but it was all optional. I think for I think this goes for almost anything, but like what you put in is what you get out of it. So my roommate and I, we would just I'm not sure if this was like the best idea, but my roommate and I, after class ended, we would go straight to dinner. That way, after dinner, for the rest of the night, we could like finish all the optional homework. And during class, we would like take notes. She had like a Google Doc, and I would like take like hand notes, and then we'd compare notes. Um, but the homework, there was a lot if you want to do all of it, and I think it definitely helps with like understanding and retaining the material. If we had questions, we could stay like a little bit during lunch, or we would come early sometimes. Um, but yeah, there was a good amount of homework.
And you also doing study group, right?
Oh yes, and then at night, I think we would all come together. I think it was me and my roommate Bright and a few other people. We would go to like the study room in the middle of the dorms, and we would just like help each other with homework. Bright was really good at debugging. So yeah.
And their study room is right next to my dorm, so I was staying there, uh, and it's like right next to it, and so they stayed pretty late. Yeah, so I know the kids go to bed late. Yeah, okay,
Yeah.
very
So there was definitely an advantage if you were staying in on campus because you got that first off you got the experience, kind of like the dorm experience and everything, right? So that was fun. But that kind of collaborative experience where you could work with your partners, and that was encouraged, right? Because that's kind of real world stuff. Um, but for those who were commuter students like Richard, that may have been a little bit of a struggle. However, what we tried to do in the class was in the very beginning we would go through hints and solutions on the previous assignment, right? That for the evening and just to make sure that everybody kind of understood what was going on, and then provided some time during the class that students could work on things, and at that point they could collaborate and ask the TAs and the teacher questions. Again, it wasn't something where I was very strict about you must do your own work. You can't help your neighbor. This is supposed to be a fun camp where everybody is going to be learning together, and I think we had that environment. Even had we had what it was we had like foosball in the room, and there was a pool table, and so everybody got to take a break every once in a while because it's a pretty long day when you're going from 9 to 5, and so just having little breaks here and there where everybody got to kind of decompress was actually very helpful.
very good. Thank you, Miss Marrow. Okay, so we talk about yeah. So let me just ask. I don't know whether Claire and Bride, did you attend any of the weekend? I know one. Maybe you didn't attend. All right. Did you attend the weekend activity or one day at least, or you skip both?
We were there for the first one.
Okay, for the Stanford tour and also the Italy. Yeah.
Italy, yeah.
Italy, that was good. Yeah. So we'll think about it. I want to, try to see whether we want to do something else or something different. But can you talk about your experience on the weekend? Maybe Brian
Um,
and you.
I thought it was really fun. I really liked I think the Stanford tour was nice because I've never been there.
Okay.
And I didn't go on the tower to like the top, but maybe Bright can speak to that. I think it was good that we got to go outside a little bit. Um, but I will say, like, if you get car sick easily,
Mm.
it might be a little tough.
Oh, you mean driving?
Yeah.
Yeah. We had a bus. We catered a bus to drive. Yeah. So and Brian, you want to talk a little bit about your weekend experience?
Yeah, I agree with Claire. Like, it's definitely a lot of fun, and I especially really enjoyed the Stanford tour. I did go up to like the tower they had, and the view was pretty nice. And also what Claire said, like it is a long drive from Berkeley to Stanford. Like, I think maybe like an hour-ish. But if
Hmm.
you do get car sick, like it can be a little tough.
Yeah, I see. I see. Yeah. So, and you guys also went to the marina, right? To see the sun setting? Like, yeah. Okay. Some of the students went. I took them during the weekday. I took them up to the Lawrence Science Lab and see the view. So we have a lot of Berkeley is very beautiful, right? Do you like Berkeley, Claire and Bright? I know Richard, you guys, your brother attends here, so I'm not gonna ask you. But you guys, do you like Berkeley, Claire?
I didn't I spent most of the time like around the dorms, so I didn't really like go on campus a lot. But one thing I really did like was Dan brought a couple like Berkeley students to like tell us what it was like. And one thing I think Tim said this, one thing I really appreciated was that Berkeley has really good um like they care a lot about social justice and there's like a big culture around that. So I was really impressed by that. I like the student atmosphere. Yeah.
Yeah, very good, very good. Yeah. So we have some, cake, we have other talks as well. So, okay, so we'll save pretty much everything for the parents and students to ask. And yeah, about 15 minutes. We'll open up to the floor. Do you guys have any questions? You can type in the chat or just ask. Unmute your microphone. Did we answer all the questions? Mainly about the age, right? And I give a lot of links. No questions at all? Hmm. Nothing.
We'll provide Dan will provide the slide deck that had and there's my contact information is there. So if you have any questions specifically about the curriculum that we cover, the pace, anything like that, just reach out to me. I'm happy to answer any questions.
Okay, maybe I can highlight it a little bit about like we do college counseling. So a lot of parents gonna ask like, okay, if I'm not gonna do study engineering, it's worth it. But as I told you, we have students like public health. If you come into UC Berkeley or many other schools, that letter science is you can study bio, study economics, and I'm sorry, yeah, one second. Sorry, I have a little bit background noise. Yeah, so this this whole curriculum and experience is not just for engineering students. So Mr. Mauro, is that an accurate assessment?
Well, I mean, everybody knows now, and everybody has used, I'm sure, either their favorite LLM, right? Whether it be ChatGPT or Gemini or Claude. Um, and you can use it for anything, right? I mean, there's bioinformatics, there's finance, in biology. These areas, machine learning is really sort of the base that established to that builds upon all of these agents, right, that are in use today. Um, and so what we try to do is teach that fundamental piece, right? And we're not designing LLMs. If you want to do that, come see me, and I teach a class in natural language processing. So there's a big lift to get to that point. But the applications are everywhere. And, as you read about every day, right, where they talk about, how AI is going to take everybody's job away. Um, to understand how to use an agent, and understand the fundamentals of how they're built and how they work, is going to be pretty important. So, whether you're a biologist, or a finance person, or an attorney, um, or an engineer, right? I mean, even in engineering now, the automated workflows are becoming more and more kind of prolific. Using AI to do uh, documentation and testing is pretty mainstream now. So understanding this kind of this basic stuff, no matter what you go to study, I think is pretty important. And so, yeah, I mean, it's very widespread.
Mm, yeah, very good. Yeah. So, yeah, Trump brought a lot of CEOs to China, and Jensen was interviewed during the visit, and Jensen made a comment saying that, "Oh, I admire, AI is in all the industry, in manufacturing, in bio, in education, in China." So AI is becoming a tool. Like, I did a blog before. It's like a mother language. Everybody really needs to study AI and use AI to improve the productivity and efficiency. Okay, thank you, Ms. Mauro. So now we are talking about the time. Yes, the parents are asking the details. The camp is actual camp starting is Monday, July 27th, but students can check in. That's UC Berkeley's rule. Residential students will be staying at, last year was Unit 2. This year, I'm not sure. Unit 2 or Unit 1, they will assign, but they're right next to each other. And right next to also the Crossroads dining room, and you can check in after 3 p.m. They open up, and then check out for residential students is August 8th on Sunday morning. Okay, I think 11 or 10. I forgot. There's some strict time from UC Berkeley, and instruction we start at 9:30. Usually kids stay late. That's why it's hard to have at 8 o'clock. 9:30 to 12:30. It's very packed. Of course, Miss Maru will give some break here and there, small breaks. Students going to walk 5 minutes to crossroad dining, and it's buffet. And then the instruction time starts at 2, and that's another 3 hours between 2 to 5. And then, you know, if commuter students want to stay here and hang out, no problem. But most commuter students have their schedule, either parents picked up or they have BART schedule. I would like, Richard, you don't live too far, but we have students commute from South Bay. That's very challenging. So this year we do have a few Bay Area students. They will all be residential because they're much further than you. Okay. That's where the schedule is. And at night, as Claire said, a lot of work to do. So hopefully that explains to, so residential students will have signed, you will report on Monday, hopefully before 9:30. Okay, that's for sure. Mhm. Okay, so there are a couple of things I want to highlight a little bit. One is a lot of students are doing bio now. People think our software is like, the cloud can do it, and they're doing bio. And so if you're in bio or in business or in econ or in any other political science, psychology, you will need to know AI because there will be a lot of data to be processed, and doesn't matter you do research or work. So my anecdote here is my younger son, was a UC Berkeley student, just graduated. His first research project was offered by UC San Francisco and UC Berkeley joint program, and it was a bio program, and the professor is MD and PhD. However, my son was going after big name, so he got admitted into Berkeley Artificial Intelligence Lab doing robots. So he thought, oh, the lab has much more fame. So he joined and he didn't like it. And this, he switched to pure mathematics. So he's going for PhD for pure mathematics. But here I tell you, and this time he did not choose go after the name. And he said when he choosing PhD from the Cornell, the CMU, and UIC, he told me, which I didn't know. He said, "Oh, I did not get experience with. I did not choose the other professor. Now all the students doing research with him, their 5 year PhD, working for his startup. You know, his startup is paying the students $200,000 a year." And so the PhD students are working for the MD, PhD professor, the joint program, getting paid $200,000 a year. And in 5 years, I get a PhD. So what I'm trying to say is he has a CS degree, you know. So the CS, the computational skills are very, very needed for the biofield, much more needed than ever. So we were talking, you know, we coach a lot of students, and some students are in neuroscience and bio. They are very having a hard time getting research program when they get into college. And the first thing we tell the students is you need to learn machine learning because all this professor has all the data. They want your help. So that's another anecdote about the AI, the machine learning, all the skills taught in the camp is going to be useful for whatever subject you study. So that's why, you know, that's the emphasis here. Okay. So any other questions? So have any final comments for our students and parents? Maybe starting with Richard. hmm Like why they should enroll.
Um, well, in general, like AI, like it's easy to see AI just like as like a big black box. You feed it your what you want, you tell it to do it, and it just like spits out a response, spits it out. And it's really easy to just like fall into like a trance of just like using it and not really thinking about what's behind it. But I think it's like really important for like especially in this day and age and in this like era society, it's really important to know what, like what's actually going on and what's actually really happening in the background. And I think this campus like a really good starting point to get that new perspective. Yeah.
Very good, very good. Thank you, Richard. Yeah. And Claire?
Um, I think what Richard said pretty much sums up like why you should go to the camp. Another more like I have like a personal anecdote. This also has to do with Liam. He's Dan Dan's son and he was a TA last year. When I first came to the camp, I had like a pretty not that stable um like I guess knowledge of code and computer science, but I was talking to Liam one day during lunch and I was telling him like, oh, I want to do like some sort of recommendation system project. Like this has like always been something I've wanted to do. And I was telling him about it. I was like, do you think I can do it? And he was like, yeah, I think you can do it. I was like, what? I don't really know how to do it and I can't do it. He was like, there's no can't. And so I think like the camp really helped me understand what was going on, like what Richard said. But I think like the atmosphere is really nice in that like you study really hard and a lot of people here like encourage you to like try things you've never done before. And I really like that about this camp.
Thank you, Claire. Thank you. And Bright?
Yeah, they both had really good points. Another thing is like this camp, like, even if you have like no experience like with AI or like you have a little bit of experience with AI, it's like a really good like camp anyways because it like really goes like deeper than like what you might traditionally do. Like with AI, like it really talks about like the fundamental concepts of it, which I think was really fun and interesting to learn about. And then another thing is like it's just like a really fun camp. You get to like meet new people and hang out with them and like have fun.
It's great. Thank you, Bright. And we'll give closing remarks to Mr. Mauro.
All right. Well, hopefully everybody got a good feel for what the camp is about, and thanks to all the former students that were there and that will be attending. So we hope you got a lot out of this. And if there are any other questions, please reach out.
Okay. Thank you all. I think we'll end the session and really appreciate your valuable Friday night. And thank you all. And you can know how to reach us. I will enter the email address, phone number, WhatsApp, this last, yeah. And okay, so I will enter here. I really appreciate all your help, and I will see you here in July. We'll have a great time. And my aunt will make some great food for all of you. And she's here again. Okay. Yeah. Thank you all, and I'll see you in July. See you all. Okay. Bye-bye. Bye.
Thank you.
Bye.